Problem number 9. Looks like we want to do some quick trig evaluations by hand. This will just involve some pictures. 11 pi over 6 is 330 degrees over here in the fourth quadrant. The reference angle would be 30, so I can quickly make myself a 30, 60, 90 triangle. It would be the 1 that's negative here in the fourth quadrant. I want the sine ratio, looks like negative 1/2. Opposite over hypotenuse. Cosine 5 pi over 4. Let's see, that's a 45-degree reference angle here in the third quadrant. So I can form up my triangle. Both of these ones would be negative in the third quadrant. And the cosine ratio would be negative 1 over root 2. And I know when I rationalize that, I'm going to get negative root 2 over 2. Sine of 3 pi over 2. 3 pi over 2 is quadrantal, so I should go unit circle. This is the point 0, negative 1. Sine is the b coordinate, so the answer would be negative 1. Cosine of 5 pi over 3. Let's see, 5 pi over 3 is 300 degrees. So that's around here somewhere. The reference angle would be 60 degrees, meaning once again I can form my 30, 60, 90 triangle. It would be the root 3 that's negative here. Cosine adjacent over hypotenuse. Looks like 1/2. 7 pi over 4, that's the 45-degree spot in the fourth quadrant. Again, forming up my triangle. 1, 1, root 2. The vertical leg would be negative. Sine is opposite over hypotenuse, which when I rationalize will give me negative root 2 over 2. And then cosine 5 pi over 6. Let's see, that's 150 degrees. Reference angle would be 30. Drop the perpendicular. 1, root 3, and 2. The root 3 would be negative. And cosine is adjacent over hypotenuse. And we've got it. Problem number 10. We've got a couple of triangles. We want to find the values of x and y. Just a quick glance here at this first picture. This is not one of our special triangles, so I'm going to have to set up some trig ratios. This first one is pretty easy though because I'm in the first quadrant. I could just say sine 43 degrees, for example, equals opposite y over 16. All I would have to do is multiply both sides by 16, and now I have an expression for y that I can type into the calculator. 16 sine 43 in degree mode is equal to 10.9. To 2 decimal places, 10.91. And then to get x, I could use the Pythagorean theorem, or I could just set up the cosine ratio. So cosine 43 degrees would be x over 16. Same algebra here, multiply by 16, and then just visit the calculator. 16 cosine 43 degrees is equal to 11.70. Part B is very similar. The only difference is I'm in the second quadrant now instead of the first quadrant, so I have a couple of choices. Obviously, this angle here is 20 degrees, so I could ignore the quadrant information, just work with the triangle, fill in the lengths, and then figure out the positives and negatives. Or I could just use that 160 degrees, which is the actual angle that formed that triangle, and set up my ratios that way. Then the sines will work out the way they're supposed to. So for example, I could say sine 160 degrees equals y over 5. That's very true. I can get the y by itself by multiplying by 5, and then go to the calculator, and that will be my value for y. 5 sine 160 comes out about 1.71. And then I could set up a similar situation for x using the cosine function. Cosine 160 degrees would be x over 5. And then get the x by itself and type that into the calculator. 5 cosine 160. And that comes out negative 4.70 to 2 places. Notice that since we used the 160 degrees, the negative came out correctly. We would expect this x to be a negative number, and that's exactly what the calculator had shown us. If I had used 20 degrees, I would have gotten the same values, but I would have had to insert this negative myself based on the picture. Problem number 11, a couple more triangles. Now I want to find C, the hypotenuse, as well as theta, this angle. These are not special triangles, so we will use the calculator. We are giving approximations. We're working in terms of radians for the angle. So in part A, I guess I would find C just using the Pythagorean theorem. I would have c squared equals 7 squared plus negative 4 squared. That's 49 plus 16, which is 65. And so c then, of course, is just the square root of 65. Square root of 65 is around 8.06. So that part is done. What am I going to do for theta? Well, I have a couple of choices. I could just concentrate on the triangle, on this little angle, and then make my adjustment based on the picture. Or I could try to find that big angle directly. And of course, I'm going to end up using one of the inverse trig functions. There's only one of the big three that knows about angles in the second quadrant, and that's the inverse cosine function. So what I'm thinking is, if I set up a cosine ratio for this angle, the inverse cosine button will actually find it for me. Cosine theta would be adjacent negative 4 over hypotenuse, which is that 8.06. Well, that means theta itself would just be the inverse cosine of that ratio. Now, I'll want to use the full value for the 8.06, but the calculator is going to give me exactly what I want. Sine inverse, that's only going to give me angles in the first or fourth quadrant. Same thing with tangent inverse, but cosine inverse can give me exactly what I want here. I do want the answer in radians, so let me go to radian mode, and then I'm going to type in cosine inverse negative 4 divided by that last answer we had, that 8.06 answer. We'll use the whole thing so we don't have any rounding errors. And that gives me 2.09 radians. And so we found what we wanted for part A. Let's look at part B. Once again, not a special triangle. I would find c using the Pythagorean theorem. C squared is 22 squared plus negative 24 squared. I could work out those numbers like I did the last time. I don't really have to, though. I mean, I know I want a decimal, so I could just type it in just like that in the calculator. Square root of 22 squared plus negative 24 squared comes out to be 32.56. So there's C. Now what about this angle theta? I'm going to have to use one of the inverse trig functions. I am in the fourth quadrant, so I'm thinking I should either use inverse tangent or inverse sine. That still won't quite give me exactly what I want. Inverse sine or tangent has not heard of an angle bigger than 90 degrees, but it will at least tell me this angle. Right? Those two know about angles between negative 90 degrees and positive 90 degrees. Let's set up a tangent statement, then I can use the numbers that were in the original picture. So I'll say tangent alpha, I'm going to call this thing alpha, is equal to opposite negative 24 over adjacent 22. Alpha then would just be the inverse tangent of that ratio. I could reduce it to negative 12 over 11 or leave it alone. The calculator won't care. Let's see what the calculator gives me here. Tangent inverse of negative 12 elevenths. I got negative 0.83 radians. Now that's not the final answer. That's this angle here. But that angle is coterminal to the angle I want. In fact, if I just rotate one full revolution from that, in other words, if I add 2 pi to what we just got, then I will have angle theta. I'll have what I want. So back on the calculator, just type in plus 2 pi. That takes me to the positive angle I was looking for, 5.45 radians. And so we're done. We found the c and we found our theta.